You are listening to the Archaeology Podcast Network.
The Archaeology Podcast Network is sponsored by Codify, a California benefit corporation. Visit Codify at www.codifi.com. Okay, I'm here with the, I think, first ever live interview for the Archaeotech podcast, aside from some small conference stuff we've done. And I'm here with Peter Wigand, and he originally contacted me actually a few days ago from this recording because I own a CRM firm, and I'm not sure how you found my website, but he contacted me because you do pollen analysis and things like that for archaeological projects, and wanted to see what was going on there. So I said, well, that sounds like an interesting topic for a podcast. So I figured I'll come down to UNR here and the University of Nevada, Reno, and talk to you about it and talk to you about your work. So why don't you give the listeners just a little bit of background on yourself, where you came from and how you ended up in Reno.
Yeah, originally I came from the Pacific Northwest, Portland, Oregon area along the Columbia River. And as a kid, I used to look for arrowheads. And the interest developed into wanting to go do it as a career potentially. I went up to the University of Washington as a undergraduate and started out in anthropology. I was going to do Middle Eastern archaeology. The person who was teaching Middle Eastern archaeology actually left, and I ended up doing Mesoamerican archaeology. Mm-hmm. And I also combined that with classical archaeology because there was a classics program at the University of Washington. And I had already taken Latin, but I took Greek and Arabic as well. Nice. At the University of Washington. And then I graduated and got drafted and ended up as a combat medic during the Vietnam era. I didn't go to Vietnam, but I ended up doing maneuvers in Europe and stuff like that. But when I came back, I went to Washington State University and started in the anthropology program there, and actually ended up doing a master's degree on Western Mediterranean archaeology. The professor I was working with, Henry Irwin, actually had materials from southeastern Spain, and I ended up doing a study that involved the Epipaleolithic through the late Iron Age materials from that cave. So that encompassed both pottery, lithics, burials, the whole ball of wax. Mm-hmm. And I combined with that some environmental work as well, because the program at Washington State University was quaternary sciences, and that included not only physical anthropology, but also geoarchaeology, stratigraphy, also had a fallen analysis aspect as well as pollen analysis aspect. So after I finished my master's degree, I'd already taken half the courses to do my PhD, so I stayed there and actually finished my PhD there as well, and ended up doing a project in South Central Oregon, the Steens Mountain area. It was tied into the Steens Mountain Prehistory Project, and I worked under Dr. Pete Maringer. Mm-hmm. And I did pollen analysis from basically a MAR, an explosion crater, volcanic explosion crater. Did a 6,000-year record, high resolution, sample every 25 years. I looked at the climate, vegetation history, and climate history derived from that, and tied that into marsh, basically usage by people within the region. And when I finished that up, I actually ended up being invited to come down by a colleague of mine from Washington State University who had gotten a job at the Desert Research Institute, Jonathan Davis. Mm-hmm. And so I started working at the Desert Research Institute I actually came down a couple of summers, 85 and 86, and then started working at the Desert Research Institute in 1987. And while I was there, I worked on projects for basically land agencies like the Bureau of Land Management, the Forest Service, the Bureau of Reclamation, and so forth. doing primarily pollen analysis, but I was also doing work with the archaeologists at the Desert Research Institute doing pollen from their sites as well. So it was a combination of doing pollen analysis for vegetation history reconstruction and climate history reconstruction, as well as looking archaeological pollen from archaeological sites to look at use areas and artifact uses like pollen washes on milling stones and things like that.
Mm-hmm.
So I was doing a combination of those things at the time. I was there for about 11 years. And then in 1999, I had an opportunity to go to I actually applied for a Fulbright, senior Fulbright fellowship. And I ended up going to Jordan.
Mm.
And then I spent a year teaching in Jordan and doing some research in Jordan as well. I taught at Yarmouk University in Irbid, Jordan, in northern Jordan.
Nice.
And I was the only American there for at least half of the year. It was really pretty wild. It was during the period of time when Zarqawi, the terrorist, was just getting started with his organization.
Mm.
He is actually Jordanian. He wasn't Iraqi. He moved to Iraq later on, but he was Jordanian. And he ended up doing a lot of, threats against the U.S. Embassy and so forth. So
Right.
we were on call all the time. They would send us emails and stuff like that, say, okay, Zarqawi's made another threat and so forth. So we'd have to go underground, so to speak. But I was never worried. My students, kept me pretty sheltered as far as, they watched my back,
Yeah.
at the university there. Plus, I had the Arabic before, and I'd also worked in Egypt before as a graduate student. When I was at Washington State University, I was in Egypt twice. We did work in the Western Desert. We actually took pollen samples out of the Birkir Qarun, which is a depression southwest of Cairo, and got about a 3,000 year pollen record out of that.
Wow.
Plus, I did archaeological survey in about 1977 with a guy named Fekri Hassan, who was a geoarchaeologist, and we did survey in the Western Desert as well as the delta of the Nile. But when I returned from Jordan, I basically in 2000, I started my own consulting business. Plus, I became adjunct faculty in the geography department here and adjunct faculty in the geology department down at Cal State Bakersfield.
Mm-hmm.
So that's when I started doing a lot more contract work for federal agencies and so forth. My firm is actually on the Central Registry, Federal Registry.
Okay.
It's a licensed consulting firm in the state of Nevada, the county as well.
Okay.
And so I did an awful lot of work, especially in the West, but occasionally I would do stuff, outside of the region as well. I did some work in Kansas. Because I had worked in a radiocarbon dating lab for about 3 years.
Mm-hmm.
I actually was a research technician in a radiocarbon dating lab at Washington State University. And it's always nice to say that, oh yes, I was in the nuclear chemistry department, but anyway, I worked in a radiocarbon dating lab, so I actually built counters.
Yeah.
We did gas proportional counters at that time. So I actually built gas proportional counters, and we did an analysis of radiocarbon samples for a lot of people from throughout North America.
Yeah.
And so I had that experience as well. So I've written papers with people that do analysis of groups of radiocarbon samples from archaeological sites and so forth.
Mm-hmm.
And then, in addition, then I started doing wood rat midden analysis, and then I started analyzing pack rat middens for the macrofossils they contained as well as the pollen they contained. And in that respect, I started working on the Yucca Mountain project, the high-level nuclear waste storage repository project. And I worked on that from about 1989 through 1999, so for about 10 years I worked on that. And I basically, with especially that analysis, we were able to do reconstruction of vegetation history in areas where pollen records were not available.
Right.
Especially, there's sort of a divide about halfway through the Great Basin. If you go north of there, you've got plenty of localities to do pollen analysis. You go south of there, they start dropping off. The preservation is poor.
Mm-hmm.
So we started using the pack rat bin analysis. And the pack rat bin analysis is nice because it gives you the added ability to do identification of plants down to the species level.
Wow.
Whereas pollen is generally the genus level.
Okay.
And sometimes only the family level. But the combination of the two, we're able to look at trends in climate, and there's trends and changes in vegetation, which reflect changes in climate through time. So we did that. We worked on that project for, like I said, until about 1999. And then I had the opportunity to go on this, basically a Fulbright fellowship, and went into the Middle East. Projects that I've done since, I've done a lot of work, like I said, with archaeological sites. I've worked with groups like WCRM, Statistical Research Incorporated, Far Western, groups like that. But I've also done stuff for federal agencies like the Bureau of Reclamation. For instance, we cored Gray's Lake in southeastern Idaho, and we're able to do work there looking at, in particular, we focused on the last 3,000 years of vegetation history there, although we actually have a 10,000-year record that we have potentially we can work on yet. But we were interested in marsh history there, so we're looking at marsh history, and then that could be integrated with what we know about people and marshes in the region as well. So that's what I've always sort of tried to focus on. Not just looking at environmental history. Obviously, the Yucca Mountain Project, we were looking at fluctuation in rainfall because we were looking at cycles of wet climate that might cause problems for the waste repository site.
Right.
But in general, what I've been able to do is take that information, especially for the Holocene, and wed it to what we know about the archaeology in this region as well. So, for instance, my dissertation, when I looked at central Oregon, there are some periods of time between about 2,100 years ago and 1,100 years ago where we have significant shift in climate towards summer rainfall. Lower annual rainfall, but increased summer rainfall. That increases the grasses, which enhanced bison expansion, because we have evidence for bison expansion both on the Snake River Plain and in Oregon as well. And we have people, moving in, like the Fremont, the freebooters, as they call them. Basically, the Fremonts moved into the Utah region and Snake River Plain during this period of wetter, summer wet climate. Mm-hmm. And what's fascinating is that's how I sort of made the jump to the Middle East, because we have the same period of time in the Middle East. So now what I'm doing is, still looking at people and the impact people have on the landscape and so forth. But what I'm really interested in is looking at similarities in climate across the globe, in particular the Middle East and the Near East and the Mediterranean and the West, because those are similar climates in many ways, and see how people responded to those changes in particular. So I'm still getting back to my archaeological roots, even though I'm doing pollen analysis. And this is really what my focus has been and still is today, is to wed the two. Now, the thing is that I've also been involved in some projects like in Southern California. With statistical research, I worked on a project in the Bayona estuary. And there we had a fairly long record. Other people took the cores, but the data, I was able to analyze the data, reanalyze them, and find some interesting correlations between where people were in the landscape and what the vegetation was like at the time. So for instance, during the mid-Holocene, between about 8,000 and 4,000 years ago, there was an expansion of the chaparral in Southern California based upon the pollen records from the Bayona estuary. And that's the time when people moved away from the coast and moved into the interiors. So they were using resources in the chaparral away from the coast. As the chaparral started contracting again about 3,000 to 4,000 years ago, people moved into the coastal region again. And then during this period of time that I mentioned, between 2,000 and 1,100 years ago, when you have increased summer rainfall, people are very heavily concentrated into that, what they call the the Los Angeles Prairie, which is that area from about the Loyola Marymount or the Bayonne Estuary south to basically Redondo Beach in that area. That was used to be huge prairie grassland with ephemeral ponds, seasonal ponds that people lived around, harvested the grass seeds and stuff like that. We find increased grass seeds and diet and so forth during that period of time. And that was due to climate change. People say, "Oh, it's really bad to be an environmental determinist," but I am, because I said, culture is a good buffer, but it isn't that good as we see today. That people still have to respect the environment and use what the environment allows them to use.
Right.
They have parameters, and during periods of really bad times, those parameters that they can operate within gets much more limited. And then during periods of good climate, then they've got a broad latitude of what they can do and what Mother Nature allows them to do, basically. And so that's what I've been finding. That's what I find all through the world. And we can see that in the Middle East, where I've been working. We see these same cycles. What people are able to do, what they can't do. This is really, Mother Nature's sort of, I'm not going to say control, but she is sort of the baseline. And we can operate within the parameters that she lets us operate.
Right. Well, and that's one of the things I want to ask you about, because you mentioned a few times that you can see where humans basically followed the species of plants with climate change. But at what point in your, when you're doing analysis, because we were talking about Italy and then, other places before we started recording, how obvious is it to somebody like you that does this analysis when it's clear that humans are now causing these changes? They're no longer following the climate change. They're causing, some of the stuff that's happening. How is that distinct in the record?
Yeah, two ways. And because I'm working with geomorphology, that's sort of an additional way of looking at it. But usually what we look for in the pollen record is some kind of significant change in the natural vegetation. In the West, it's less obvious, although we have really great examples of people using fire. So charcoal in the record is one of our tools. And I've been working with charcoal for longer than I care to suggest. But the thing is that charcoal in the record can be either caused by climate, changes to drier conditions, so you have more opportunity with fuel set-offs as far as the fire is concerned, but also people burning the landscape so that they can increase the productivity of certain resources. And we see that again and again and again. In fact, one of my colleagues at Washington State University did a dissertation looking at exactly that kind of issue in the Northern Rockies, in the Missoula area, looking at fire frequency increase during periods when there was actually no climate trigger for it. And that's one way to sort of look for it. But also, we see this even, especially in the higher cultural areas, we see this use of fire, and land clearance in particular, as a real shift in what's happening with native vegetation. We have so many proxies now. We have ice core data, we have ocean records, we have stable isotope records that we can use to suggest, okay, this is what the trend is in climate.
Right.
And then on the other hand, we have these other things that, let's say in the vegetation record, that suddenly change and there's no reason for it.
Right.
And that's where we say, so this is where we start looking at what might be happening in the record. So. Okay. And at that point, then I can start getting into my Italian work.
Well, and
you're at 19 minutes.
Yeah, let's take a short break and then we'll come back to the Italian work.
Let's face it, the quality of archaeological field photography could really use some improvement. We aim to change this with the Codify Magic Photo Board. This lightweight but incredibly durable board is designed to help you take color-perfect photos of artifacts, features, and sites using almost any camera, even your smartphone. You need to see it to believe it. Engineered from exceptional quality, color-safe, high-pressure laminate, Codify Magic Photo Board is ready for tough field conditions. It's guaranteed to level up your photography. Start taking publication-worthy photos right in the field with the Codify Magic Photo Board. Available now for pre-order, visit codify.com/APN. That's codifi.com /APN today and get your promo code exclusively for listeners of the Archaeology Podcast Network.
Okay, we're back, and we were starting to answer some bigger questions, because while I think a lot of, I may be wrong on this, but I have a feeling that a lot of CRM archaeologists in particular might think that pollen analysis is simply just counting things and determining what plants were there. But there's a lot that you can tell from exactly what plants were there at a certain level and certain quantities and things like that. So in that respect, tell us about some of the work you've done in Italy.
Yeah. The Italian work I started was about 5 years ago. I was invited by one of my graduate students to join a group of Canadian and British archaeologists in southern Italy who were doing work on a Augustan villa, believe it or not, that was owned by a slave, one of his slaves during the lifetime of the slave, and then reverted back to Augustus after the death of the slave. And it's in the area of, on the border region between two regions, the Basilicata region and the Buglia region of southern Italy. So it's in the Arch of the Boot. And what's fascinating about this area is that it's always been a crossover area between many cultures. 2,500 years ago, as the Iron Age peoples were moving south into the heel and toe of Italy, we had Oscans, who were Italic-speaking peoples coming down the coast in the west, and then we had people coming across from the Balkans who were Albanian speakers potentially. And the crossover area is right where I'm working. I mean, basically, I've got a cultural divide there. Plus, we had Magna Greca, and there was the Greek colonies in the south. So we had the Greeks in the south, we had the Italic peoples in the west, and we had the Albanian peoples in the east. And then that switched around at about 1900 years ago, where you had the Byzantine Empire in the south, and you had north of there, you had the Germanic tribes started moving into the area, you had the Lombardies. So that was about 1600 years ago. 800 years ago, Muslims came in from North Africa and set up a caliphate in Bari. And then in the 11th century, the Normans came in. They were mercenaries that operated for both sides. They operated both for the Byzantines and also for the Lombardies. And eventually the Normans played both sides for the middle and took over the region within about 70 years. And since then, the Normans have been sort of, let's say, king of the mountain in southern Italy since then. And all the castles that you see in southern Italy, most of them were built by one king, one Norman king, Frederick II. I mean, say, who built this castle? He said, Frederick II. Who built this guy? Frederick II. It's like he was just like Edward in England, who built all the castles in Great Britain when he took over. And it's the same thing in southern Italy. Frederick II built these castles everywhere. And they're the best tourist attraction, I think, one of the best tourist attractions in southern Italy. Although you've got the Greek ruins, you've got Roman ruins, southern Italy is an incredible region. But I began working there because originally we were going to do pollen. We had already looked at pollen from the villa site. And there's some pollen preservation there, but I thought it would be really nice to put the villa into a regional pollen context, in a vegetation context, because we're talking about an area that some people have suggested the region was in fallow, in other words, that had it been abandoned, the agricultural lands. Other people say no, it hadn't been, and so forth. So we were interested in trying to decide what was going on in the region. And so we started looking for pollen records, and there are a few long-term records available, but they're very coarse. There's a volcano, Monte Volture, which is about 92 kilometers to the north and west of where I work. It's got a 44,000-year record, but only about 11 samples for the Holocene, which is a very low-resolution record. And but there are springs available that you can take pollen out of, which will tell you the history of the spring, recharge history, and things like that.
Right.
But also, by looking at the pollen, you can look at the changing assemblage of the marsh plants around the spring. That tells you a lot about the climate and also the stress on the landscape around it. And also it tells you about regional recharge as far as, when you clear a forest, what happens is groundwater recharge decreases because what happens is the water runs off.
Okay.
It isn't absorbed into the landscape, so suddenly groundwater recharge goes down. And so springs, looking at springs and the pollen records from springs is a good way to monitor regional water recharge as well, which then feeds into what's going on with the agriculture and so forth as well. But we decided that one of the best pieces of evidence that we had in the region, we did core some springs, and we've got those records. But we also have been looking at the alluvial history, erosion history of the region. And what we found was that there are tremendous, really nice cycles of erosion within the region that have occurred. At least we got some radiocarbon dates on a significant soils. We have soils in the region. 2,100-year-old soil. We also have a soil that's 8,400 years ago. That's very, very major. And we've been looking at these soils and trying to determine how these erosion cycles relate to when soils are developing and what people are doing in the landscape. So what we started doing is collecting samples, mapping exposures. We also then got to the point where we were able to use the soils as stratigraphic markers. They're like volcanic ashes, and there are volcanic ashes in the area too. Vesuvius ashes are in the region.
I bet.
So, I mean, we have the 2,800 and the 3,800 year Vesuvius ash in the region. And so we have stratigraphic markers. They're so good, in fact, the soils, that there was an excavation of an Iron Age house complex, village complex, a small village complex. And people were saying, well, how old do you think that is? And I said, well, it's older than 2,100 years old because there's the soil right over the top of it. It turned out to be 2,500 years old. So
it's like as good as Mazama ash.
It's as good as Mazama ash. When you have a soil like that, boom, you've got it nailed.
There you go.
And so I've been looking at exposures throughout the region. I've got like 23 to 24 exposures that range in age, not only through the Holocene, but into the Pleistocene. So I have Pleistocene exposures that go all the way to the last interglacial, 140,000 years ago. And then I also have some much older deposits that actually reveal the lower Pleistocene record about 2 million years ago, which shows the transition between marine deposits and coastal deposits and then terrestrial deposits. And in southern Italy, it's so cool because you're dealing with two things are going on with the landscape. One is base sea level changes with ice age, non-ice age, so glacial, interglacial cycles of sea level change. In addition, you have this cycle of, not a cycle, but this gradual rising, and it's not gradual either, because what seems to be going on is you have these punctuated rises in the base level of the landscape. In other words, elevational increases in the landscape due to basically the plunging of the African plate under the European plate in Italy. And so we have these, roughly every 100,000 years, we get a significant rise in the landscape relative to sea level. So you've got sea level fluctuating, you've got the landscape rising up, and so we can look at these changes in time that change the base level of our streams within the region as well. The area where I work is about 300 meters above sea level, and it tilts down to the area around Metaponto, which is on the Gulf of Taranto. And there are some major faults just to the east of where I work. There's a 200-meter fault that actually exposes Mesozoic limestones in that region with dinosaur trackways and all kinds of cool stuff like that as well. But what's really cool about it is that this region, because it's on the south coast and on the route to the south coast from Rome later on, when we get into the major cultural periods, the empires, it's a route of trade and also agriculture, because today this is wheatland. And in the past, it's been an area where grapes and olives were grown, and even today, it's also an area where grapes and olives are grown as well. So it's an area that has tremendous human impact, and that's always the big question: is when did it occur, and how can we recognize it? So we have these regional pollen records that people have been playing with and saying, okay, well, this is when people are coming in, and we think there's more influence here and than in the past, but it's all very subjective. And so we said, well, what would be a good way to sort of take the pollen records and tie them with some other kind of data, proxy data, and come up with a really good record of what's happening in the region. And these alluvial records are really a good way. It's erosion. And people have tremendous impact, especially in that area where it's agricultural peoples, have a tremendous impact on the landscape. And what's really fascinating is that we've been able to put together a model using a climate model, a mesoscale climate model that was developed by Reed Bryson back in the 90s and has been applied to the West in a couple of different areas already. And there are a lot of people that have used this model for tying in archaeology and climate change together in one kind of big package. Mm-hmm. So we looked at it and combined it with a model that was suggested in the 1950s already by some people in the Midwest. They were looking at sediment yield as a result of effective rainfall. And the whole idea there is that as you reduce vegetation cover, you increase erosion rates. So that's what we were looking at. We say, okay, if we have that as our baseline model, then let's see what happens over the last 12,000 years in southern Italy. Mm-hmm. So you can input, it's a nice model because it's a bottom-up type model. You put in local weather station data, 30-year average basically, put that in basically precip and maximum mean temperature, maximum low temperature, maximum monthly temperature, or let's say mean monthly temperature. Put those into your model and you generate 39,000 years of climate.
Wow.
And it's really pretty cool because you can also look at frost, free days, you look at that through time. There's also a module that you can do stream flow.
Wow.
You can also do storms. If you have that data available, you can put evaporation rates in as well. But there's a way to take regular rainfall data. If you've got rainfall data, the U.S. Department of Agriculture has a formula that you can use to convert it into basically effective rainfall. Mm-hmm. It's like take your millimeters of rainfall, subtract 5 millimeters, and then multiply it by 75%, and that's what your effective precip is. And what's really fascinating is that you can take that then and play it off against this sediment yield for effective precip model that was developed in the Midwest and come up with an erosion model for the last 12,000 years. And when I did that, what was fascinating is that there's an alluvial history record for southern Italy that it matched exactly the episodes of erosion that are in the real alluvial record matched the model, except for one event, and that occurred between 7,300 years ago and 6,700 years ago. And if you look at the archaeology of the region, that's the Neolithic. That's when people came into the region and effectively brought in the first agriculture, brought in grazing and so forth. Right. So it's basically the Neolithic impact on the landscape, so it's people. Mm-hmm. So we can use this model to literally extract climate, let's say, affected erosion rates from human-affected erosion rates. Mm-hmm. So it's a very nice model that way, and I can apply it to a lot of different regions. And I've applied it to the West. I've applied it in the Middle East, in Iran. And what's really nice about it is that you can use it as a predictive model as well. We can actually, if we have predicted rainfall for the next 100 years, we can actually input that into the model and suggest what the climate predicted erosion rates would be. And what we're doing in southern Italy is we're looking at archaeological survey data overlaid on the landscape, on the geology of the landscape. And it's a very sensitive landscape, so we can look at plateaus that are semi-indurated or weakly indurated sandstones and conglomerates, and the slopes are all very easily erodible marine marls. Mm-hmm. And as people moved off those plateaus onto the slopes, they had this tremendous erosion rate that increased as they cleared the forests. So that's what we're seeing, and when we see these human-impacted events in our model, those are basically people in the landscape.
Okay.
That's basically the difference between our model and what we see in the alluvial record, the true alluvial record. And what's really nice about it is that we can see over the last 3,000 years an increase in the impact of people on the landscape. We were able to put that together with the pollen record as well. And when we did principal component analysis on the pollen from the large volcanic crater that's nearby, what we were able to show was that there was a increase in the last 3,000 years of, let's say, domesticates in the pollen record. So that's what we were able to do, is to show that both the erosion record and the pollen record were having the same kind of changes at that same time.
Okay, there might have been a slight break in the recording, and I'm just going to call it out here because we had some. We're on campus here at the University of Nevada, Reno, and they came in with all these carts and chair mover things, and they're reconfiguring a room today because why not? It's Sunday. So we're going to pick up where we left off, and Peter, you were making a point about these correlational things. So continue.
Yeah, we were looking at the correlation that we found between the alluvial record and the erosion model that I've done with climate, and the fact that we could actually put human impact into the model as well by doing a GIS overlay of this archaeological survey data within the region, showing where people were living and what they were doing, and literally superimposing that on the geology. And when people moved into sensitive areas off of areas that are resistant, then what we can show is that there's an increase in the erosion rate as well. So we can use that as sort of a transfer function to, let's say, make the model more precise to predict erosion rates. The last thing is we've actually been able to use the climate model to determine under what conditions erosion cycles started and sort of are triggered in southern Italy. 6,000 years ago, what happened is that spring rainfall dropped by 50%. And that sort of created a situation where vegetation cover was much more sensitive to drought in southern Italy. And then what happened is we started a cycle of increased summer rainfall cycles at about 5,500 years ago. And we have this cycle that goes through that last 6,000 years of drought, summer rain, erosion, drought, summer rain, erosion. So that usually right after the beginning of a summer rainfall cycle, we get major erosion within the region. So it seems that in southern Italy, it suggests that these summer rains are torrential. In other words, that we're not dealing with gentle rainfall. We're dealing with some kind of torrential rainfall which exacerbates the erosion within the region. So we've been able to actually show that our baseline of cycle, let's say drought, summer rain, erosion, and then superimpose the last 3,000 years with human activity in the region is sort of the best way to explain what we see in the alluvial record within the region. And we're able to tie that into the pollen record as well. So we can actually say that it was really the major impact of people in the region did not start, we have this event at 7,000 years ago, but it wasn't until the last 3,000 years that people really made a difference on the landscape.
Okay. Well, we're going to take one more short break, and then we'll come back and finish up this discussion with Peter. Hosted by archaeologist Emily Long, Trial Tales is an archaeology podcast with stories told by archaeologists about the crazy world of archaeology. Emily weaves a tale of wonder and excitement with her intriguing questions and imaginative editing skills. Check out Trial Tales today at www.archaeologypodcastnetwork.com/Trial Tales. Now let's get back to the show. Okay, we're back, and I want to bring up, you were talking about how this model that you created is correlating with other models and other bits of evidence, but then also, when you look back where the model fails is where human activity, kind of took over and changed what was predicted. So I wanted to ask you about that, because you mentioned in the last segment that the model can be predictive looking forward into the future, but with the massive impact of human-created climate change in the last 100 years, how predictive is the model, really?
Yeah, well, the model itself is based purely on what we think effective precip is going to be in the future. So what I'm doing is I'm rolling with the bunches. In other words, I'm letting the modelers who are going to predict what the rainfall is going to be as a result of global warming, let them generate their numbers. And then what I will do is use their numbers to generate what the erosion rate is going to be. And in particular, one thing I've been looking at now, just the last few weeks, is the drying lakes in the Middle East. And we have lots and lots of lakes, huge lakes. I mean, huge, they used to be pluvial lakes that have just dried up, just in the last couple of years, in fact. And the impact of global change is going to be that we'll have reduced vegetation cover, increased erosion, and what that does, that puts sediment into the bottoms of these basins. And these are perennially dry. In other words, every summer they dry up. And they provide a source of dust then for storms within the region. In fact, when I was there last summer, in 2015, there was a massive dust storm just on the outskirts of Tehran. And we went out, we were going to look at some geology. I was looking up at the sky, and suddenly it just turned brown and dark, and suddenly it just roiled in like, I've experienced these dust storms in Egypt years and years ago, and we call them Hamassin because they occur in the 5th month, May. And this was May. And it was amazing just how everything disappeared.
Wow.
I mean, it was just incredible. It was all just dust. And it doesn't only come with dust, but it comes with lightning and thunder and the whole spiel. It just comes at the same time. So what happens is that this is going to increase with global warming. And so what we're interested in then is providing information for them as to what they might expect, especially in the north. Most people are looking at the lakes, Lake Urmia in the north. They're looking at Lake Mahroulou in the south, close to Shiraz. These are all major lakes, and they're very interested in seeing what will happen with these lakes. And they're especially critical because the dust from these lakes have been shown to have mercury, lead, arsenic, radionuclides. And there are cancer clusters starting to show up downwind from these large lakes. And it's especially crucial. The one place that I may be going in the future is Tabriz. And Tabriz is downwind. It's a city of 6 million people downwind of Lake Urmia. And they're only about less than 100 kilometers away. And the impact there is going to be incredible. And I have students, when I taught English on the internet, who live in Tabriz. They have little children and so forth. And these kids are going to suffer. So in that sense, what I'm interested in, I've been working with people at the Desert Research Institute at mitigation. There's a huge mitigation project going on Owens Lake, where they put down mats on the bottom of Owens Lake to actually retard the dust. And actually what's been happening is vegetation starting to grow in these basically mats on the bottom of Owens Lake. And that's what they're looking at doing at Lake Urmia as well. So we're looking at mitigation.
So there's really nothing we can do to put more water back in the lake. So they're just looking at what they can do to reduce the dust when it does happen.
And this is the problem, because partly there's a big argument about whether it's human waste of water, because they changed the agriculture in the area. They went from plants that were adjusted to the region, to trying to grow sugar cane and putting orchards in and things like that. But so they're going to try to pull back on that. And I actually suggested something very Native American to them, because all around the lake they have Phragmites communis, common cane. And Native Americans collected the little sugar beads from common cane,
Right.
and that's what they ate. And when I showed them, I took some sugar cane and beat it, and the little sugar beads, they said, "We didn't realize that." And
Nice.
so there's potentially a whole new crop, native crop, that could be used at Lake Ormia that wouldn't utilize irrigation water
Right.
for sugar cane. They could instead have common cane sugar. And that would be, natural, organic. They could actually, sell that on the international market that way.
Right.
And it's come to the point where this is outside of anything that deals with nuclear agreements or anything like. We're talking about humanitarian work, because we're actually looking at ways to prevent major catastrophes, health catastrophes within the region.
Right.
And this is what my interest is in that area, as well as southern Italy, because there we're looking at the collapse of the basically pasta wheat industry in southern Italy. This is a major wheat country, and it's going to disappear if we don't do something about it.
Right. What's the sort of political response to your work in Iran? I know the United States doesn't have the best relationship over there right now, but
it's variable, because what's happened is that the Iranian government, they're all for it, of course, but the State Department is for it. The only concern that the United States has is right now is still the exchange of money.
Okay.
But there are many programs that are in Iran that are being funded by the United Nations Development Program. And so a lot of the work on Lake Ormia and so forth is United Nations funded.
Okay.
So that's not a problem. They're mainly concerned with transfer of money, like from the United States to Iran and so forth. So it's usually, when I do anything over there, it's with their pocket of money, and anything I do over here is with our pocket of money.
Okay.
And partly, a lot of what I've been involved in is training of students. So I brought a lot of students over who are working now and being trained in, climate change projects, in hydrology and so forth like that. Things that will help the Iranians address this issue. And it's really vital, because there are predictions that if global warming goes on in Iran the way it is right now, there are potentially 80% of the Iranian population will have to move within 20 to 30 years.
Wow.
And that's 65 million people moving into Europe, into Asia, etc. And we're having problems absorbing 2 million people from Syria.
Yeah.
That's where the issue is.
As we start to wrap this up here in the last few minutes, it sounds like a lot of what you're talking about now, what you're doing, is talking about the impacts of climate change and mitigating that, and figuring out what to do with that. At what point do you think it shifted in your career from kind of studying the past to using the past to study the present and the future?
Well, believe it or not, it actually probably started 16 years ago when I taught in Jordan at the University of Yarmouk University in Irbid, Jordan. I actually taught a course called Applied Paleoecology, where I actually took past analogs of climate and what we learned about human impact on the environment and vice versa. I used that examples from the archaeological record, from the paleoecological record, to show students how you can actually take that and apply it to modern problems and issues. And, archaeology has a tremendous potential, because, where are we going to learn about our mistakes in the past but from archaeology?
Right.
And that's really the key about archaeology. If you want to take a crisis, an environmental crisis in the past, it's the end of the Bronze Age, 3,000 years ago. There was an environmental catastrophe that occurred at that time. That was basically major drought in the Eastern Mediterranean. The Nile ran dry. The fields dried up in Turkey and in Anatolia, and basically the Hittite Empire crumbled. There's an exchange of letters between the Hittite Empire and the Egyptian Empire, where the Hittite Emperor was so desperate he even offered his daughter in marriage to the pharaoh in order to get the Egyptians to send wheat to the Hittite Empire.
Wow.
So that was a major environmental catastrophe, because what happened then were what they call the sea peoples.
Mm-hmm.
The Mycenaeans started moving down the coast and into the delta of the Nile, and the Egyptians had to repel these sea peoples 2 or 3 times out of the delta. And it also goes into our biblical history, because, David fought Goliath, and Goliath was a Greek. He was a Mycenaean Greek. He was a Philistine, so from Cyprus, but he was a Mycenaean Greek. And he was only there in Canaan because of that climate catastrophe.
There you go. Okay, well,
There we go.
There you go. I'm wondering. It's just, first off, thank you for doing this, because this is fascinating.
It's my pleasure.
Yeah, it's. I think, especially, from a CRM archaeology standpoint, we often see archaeology as just, let's just get out there and dig some holes, right? But obviously, there's so many things that just intersect, so many different disciplines that intersect to really paint the entire picture of the archaeological record in the past and what we're trying to do here. Given your how you got into this at the beginning of the show here, if somebody was interested in studying this stuff, and maybe they're an undergrad right now or something like that, or not even yet, what kind of route would you suggest they take from a coursework standpoint, or
Yeah, actually, this campus has quite a few courses that people can go into. In the geography department, there are paleoenvironmental courses. You can do everything from tree rings to pollen. You can actually do, in the geology department, you can do geomorphology. I teach a course in modeling. There are other people that teach courses in climate modeling in the geography department as well. So between the geography department, the geosciences program, you can pick up a lot of these courses, but also take courses in botany, because you want to know about plants and plant ecology and so forth. And of course, the anthropology department, you have basically Chris Morgan, who teaches geomorphology, basically geoarchaeology in the department there. And so, there are a lot of courses, but what you have to do is you have to put your program together, because they aren't all in one department. They're spread across campus. But here you can do a very nice job of doing exactly that, selecting and putting courses together. Programs in hydrology, too. There's another way that you can go. So there are a lot of routes that you can take into this, depending upon your interests. And if you're coming from an archaeological interest, just keep that as sort of your route.
Right.
And then, decide what expertise you would like to integrate with that archaeology to help you get more out of your archaeology.
Okay. Well, my last question is, we talked before the show here, is I recently finished a book by David Montgomery called Dirt, and I think the subtitle was The Erosion of Civilizations or something like that. And that was talking about sediment loss on the landscape due to, like monoculture farming practices and things like that. And this is all tied together. And he had some suggestions for kind of pulling ourselves out of that, despite the climate change spiral that we might be not able to pull ourselves out of. What are your thoughts on, from what you've studied and from what you've seen around the world? How does that change maybe your daily life, or how should somebody change what they do to?
Yeah, Southern Italy is a beautiful example of that. There are people who are starting to diversify crops, and that's the big answer. I came from the Palouse, which is also a wheat-growing country, and there they did it with, contour plowing and so forth like that, and fallow and so forth. But you have to do more than that with global change the way it's occurring. You actually have to protect the landscape through a lot of the year because of the rainfall change. And so crop diversification, growing more truck crops, having more of a mosaic on the landscape as far as crops are concerned. That's one way to interrupt both the water erosion but also the wind erosion, which is also a big problem. So that's where we need to go. And instead of concentrating on, this region is great for pasta wheat, we need to think about these regions in much more diverse type of crop, let's say, mosaics, because in southern Italy, we have the added problem where the increase in temperature has allowed a bacteria to ravage the olive orchards. And so they've chopped down over 1 million olive trees in southern Italy. But that's what we need to do, is diversify. And I see that here as well, that we need to diversify our crops. We also need to think about instead of big company crops and efficiency, we need to agree that we have to be maybe less efficient to protect the landscape.
Okay. Well, thanks, Peter, for coming on the show.
You're most welcome.
Great. That's it for another episode of the Archaeotech Podcast. Links to some of the items mentioned on the show are in the show notes for this podcast, which can be found at www.archaeologypodcastnetwork.com/archaeotech. If you like the show and want to comment, please do. You can leave comments about this or any other episode on the website or on the iTunes page for this episode. You can also email us at chris@archaeologypodcastnetwork.com or use the contact form on the podcast webpage. If you'd like us to answer a question on a future episode, email us. Use the contact form on the website or tweet your questions with the hashtag Archaeotech or tag @ArcPodNet in your tweet. Please share the link to this show wherever you saw it. If you'd like to subscribe to this podcast, you can do so on iTunes or on Stitcher Radio. You can also type the name of the podcast into your favorite podcasting app and subscribe that way. Don't forget to go over to iTunes and leave a review of the show. It helps us get noticed so more people can find our podcast and benefit from the content. Also, send us show suggestions and interview suggestions. We want this to be a resource for field technicians everywhere, and we want to know what you want to know about. This show is produced by Chris Webster and Tristan Boyle, and edited by Chris Sims.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.archaeologypodcastnetwork.com. Contact us at chris@archaeologypodcastnetwork.com.
Thanks again for listening to this episode and for supporting the Archaeology Podcast Network. If you want these shows to keep going, consider becoming a member for just $7.99 a month. That's cheaper than a venti quad eggnog latte. Go to arcpodnet.com/members for more info.